Welcome to True Projects. In this video, we will be explaining about prediction and providing medication for thyroid disease using machine learning technique SVM. Introduction. Thyroid gland is one of our body's main organs. Thyroid hormone secretion are responsible for regulating metabolism. Hyperthyroidism and hypothyroidism are two thyroid disorders that produce thyroid hormones for control of our body metabolism. The machine learning is critical in the disease prediction process, and in this project, support vector machine and support vector machine with the principal component analysis is used for thyroid disease detection based on hospital datasets. These techniques of machine learning are used for the identification and inhibition of thyroid. The support vector machine is used to predict the approximate probability of a thyroid patient. If the patient has the risk of thyroid, our system has to give the suggestions like recommending home remedies, precautions, medication, etc. Objective of the project is to utilize machine learning techniques, specifically support vector machine, for the prediction and classification of thyroid disorders based on the data obtained from hospital dataset. By implementing machine learning techniques, the project aims to identify and detect thyroid disorders effectively. Additionally, the system aims to provide personalized suggestions and such as recommending home remedies, precautions, and medications for the patient at risk of developed thyroid issues, thereby enhancing the healthcare outcomes and patient management in the context of thyroid disorders. Requirements for the implementing of project are hardware and software requirements. In hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. Coming to the methodology, we have designed few modules for implementing the project. First one is to upload the thyroid dataset. In this module, we will be uploading the dataset for application. The second one is to pre-process the dataset. In this module, we will read the entire data and then remove the null values, and then we will split the data into train and test. Next one is to train SVM algorithm. Support vector machine is used for the prediction of thyroid disorders due to its ability to create a optimal hyperplane that separates different classes of thyroid conditions in the dataset, making it effective in binary classification tasks like detecting hyperthyroidism and hypothyroidism. In this module, we will apply SVM algorithm on trained data to generate model, and then this model will be applied on the test data to calculate prediction accuracy. The next one is extension train SVM with PCA feature optimization. SVM with principal component analysis is employed to improve the prediction performance by reducing the dimensionality of the feature space. PCA helps in capturing the most relevant information from the high dimensional data, making the SVM model more efficient, robust, and less prone to overfitting, leading to better predictions in the medical diagnosis task. In this module, we will be applying SVM with PCA algorithm on trained data to generate model, and then this model will be applied on the test data to calculate the prediction accuracy. And next module is to accuracy comparison graph. In this module, we will be comparing the accuracy scores of SVM algorithm and SVM with PCA algorithm. The last module is predict disease with suggestions. In this module, we will be predicting the disease by uploading the test data set. Execution. For execution of the project, first open the code folder, and this is the code folder, and this is the dataset file, and on this data we will be building and generating the models, and on this data we will be predicting the disease. And this is the main code file, and this is the run.bat file. Instead of executing the program in command line interface, we have created the Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this we can interact with the program, and this graphical user interface is created by Tkinter library in the Python. Now click on the button Upload Thyroid Disease Dataset. Select the data and click on Open. Here the dataset is loaded and it is displaying few records from the dataset. And now click on the button Pre-process to remove the missing values from the dataset and to split the data into train and test. Here we can see a dataset showing 3152 pre-processed records. Now dataset is ready. Now click on the button Train SVM Algorithm button to apply SVM algorithm on train data to generate model, and then model will be applied on the test data to calculate prediction accuracy. This is the confusion matrix of the SVM algorithm. This and this are the true predictions and this are the misclassifications. Here we can see 23 attributes are there, and in train SVM here we have 2521 records. In test we have 6301. Here SVM algorithm is initially generated the model on the train dataset and then applied on the test dataset. Here is the accuracy and here is the confusion matrix of the SVM algorithm. With the confusion matrix we will have the true predictions and misclassifications. Now click on the button Extension Train SVM with PCA Feature Optimization. This is the confusion matrix of SVM with PCA optimization. Here, after PCA optimization, we have the 18 columns in the data. Here is the SVM extension accuracy, and this is the confusion matrix of SVM extension. Now click on the button Accuracy Comparison Graph. Here on the x-axis we have the algorithm names and on the y-axis we have the accuracy score. This bar is proposed SVM accuracy and this bar is extension SVM with PCA accuracy. Among both the bars, we can observe that extension SVM with PCA accuracy is showing high. Close this. Now click on the button Predict Disease with suggestions to predict the disease. Select the dataset, click on Open. Here, in the brackets, we can see the test value, and after the brackets, we can see showing diet and medication and whether the thyroid is detected or not. Here, for this record, it is showing predicted disease as thyroid disease risk detected. So here the disease is detected, here the medication and the suggestions are given. Similarly, it has detected the other disease, that is no thyroid disease detected. Similarly, it will be detecting for all the other records also. Now close this window. Conclusion. The project demonstrates that utilizing support vector machine in combination with principal component analysis yields favorable results in predicting and classifying thyroid disorders. The successful performance of this approach highlights the effectiveness of using SVM with dimensionality reduction through PCA to handle complex medical data. The integration of SVM and PCA enhances the model's accuracy and efficiency in diagnosing thyroid conditions based on the hospital dataset. The project findings contribute to advancing medical diagnosis and prediction tasks, showcasing the potential of machine learning techniques for improved healthcare decision making and personalized patient recommendations in the management of thyroid disorders.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.